Good morning. How are you? We're going to take a shot at Unit 3 today with some enzymes. It was a beautiful morning. I actually was out on the boat this morning and the boat got sick. We had to take it back to the dock. See, you get, okay. All right. I'm ready to go. Here we go. So here we have some energy stuff. They have taken the equation for Gibbs free energy, G, right, out of the beyond the scope of the exam, but you have to understand some concepts of energy, and they're not too very more specific than that, except they do say this. Life requires a highly ordered system maintain order, right? Or they said loss of order, right? So that's about, remember, entropy. Entropy is actually disorder. So they don't say the word entropy in here, but they talk about the concept, all right? So what happens as time goes by and chemical reactions happen and life goes on is that you have to have a constant input of energy to maintain order, because a loss of order, which would be due to a interruption in energy flow, results in death. Okay, so that's kind of in general. All I guess they could ask you about energy is that it's necessary to power these cellular processes like active transport, but also like chemistry stuff, which active transport is not, but it's kind of similar in a lot of ways. Okay, does not violate the second law of thermodynamics. We'll come back to that a little bit. So you do have to know second law of thermodynamics. Okay, so here's the free energy idea, right? That's related to mathematically, which you don't need to know anymore, right? An entropy term and a total energy term. So this is energy input, output, and the disorder entropy idea. And there's young Josiah Gibbs, Chief Gibbs. So here's one of my favorite diagrams. We talked about this before. This unit is mostly about this kind of thing, where a complex molecule has lots of bond energy that can do work. And in order for it to do work, it requires breaking it into smaller, less ordered energy, more entropy down here, less order, more disorder, right? Last unit, we looked a lot at this, where a gradient, this is not a chemical reaction stuff, but a gradient can be the source of energy, because having all these on one side, or a lot of them, sets the stage for their passage to the other side. And if there's a little creature in here that can make the use of that passage, right? This is what chemiosmosis, respiration, and photosynthesis are a lot about. Okay, so the first law of thermodynamics is the total energy in the universe is constant, right? The second law, the one they specifically quoted, is that when you take some form of energy and use it to do some work, you never get everything out of it, because some of it in this transformation gets converted to heat. And heat is a form of disorder that is going to not be able to do work, and so that's what they again say they want to know, I guess, about second law of thermodynamics. Why don't you violate the second law? Why do you maintain order? Well, you have to constantly eat lunch to be able to do that. That would be like you right there. Okay, so now we have reactions, chemical reactions that release energy. The chemicals you start with, the reactants, have this much energy, and the chemicals that they get turned into have that much. So they have released this much energy. Those are again exergonic. They are often, again, almost always big molecules being broken down into smaller ones. That's what catabolic means. The flip side of the coin, right? And again, they love graphs, is about reactant molecules like carbon dioxide that might get put together into bigger molecule products that hold in them a lot of energy. To make this happen, you have to input energy. This would be like what photosynthesis is. This would be like what respiration is, right? So here we have the idea that these here, this is syllabus stuff, that processes, chemistry that releases energy may be coupled with processes that require energy. So this reaction here requires plus that much energy to happen, right? And this reaction here, ATP, releases negative that much energy. So this reaction can be used to power that reaction. That's what coupling means. Hi. This one went way over my limit, so I had to split it up into an energy one. This one is, and then there's an enzyme one coming up. So I'll finish all that stuff later. See ya. Hope you're doing well. Bye.